March 26, 2016, I have a little documentary here for you guys. I'll go ahead and break it down so people can understand what's going on.
The key to a planet's composition is its size. When planets form, they start off solid, made of rock and ice.
Alright, did you hear that? The key to a planet's composition is its size. It's very true. The big ones are hot and plasmatic, the medium-sized ones are gaseous, and the small ones are mostly liquid and solid material. So that's true. And then they have here, the planets start off solid? No, that's completely false. A planet starts out as plasmatic. Those are the young stars. And then they age, lose mass, they become more gaseous. They age more and more and more over many millions and millions of years, and eventually only the solid, rocky ball in the center is left over. But what they're going to do here is form the rocks from preformed places. I don't know where these rocks came from. And then they build on top of that in the vacuum of outer space, absent heat, absent refractory material, absent air, absent gravitation, basically with magic. If they have a Harry Potter wand, they could do that. But in reality, with actual physics, you can't just melt trillions of tons of iron and nickel from nothing. It doesn't work like that. So basically, in this theory I'm developing, it's completely different than what the Kepler space scientists believe. Sure, they can find these things with incredibly expensive telescopes and CCDs and, you know, money. But they're never going to be able to explain how they formed because they're only focused on describing them for research purposes. They don't have any intention on explaining how they're formed. Their explanations for how they form are rooted in 18th century ideas, 18th century philosophy. It all came from a big disk, and then the disk collapsed. How? They never talk about that. They never have any mechanism for angular momentum loss. So yeah, Kepler space scientists, they can find them, but they cannot interpret them. And they sure as hell don't know what happens to them. They only can say, look at that. And that's the extent of their understanding.
If they become big enough, they're able to hold on to huge amounts of gas. Hydrogen and helium, the most abundant. These become the gas giants, like Jupiter and Neptune. Smaller planets like Earth are primarily rocky and can only hold on to a thin atmosphere. Kepler 22b is in the middle. Bigger than all the rocky planets in our system, but smaller than the gas giants.
So basically what they're saying here is, what's going to happen to these objects, or what's going to happen to Kepler 22b? How did it form? What is its composition? Okay, hear on me. But what they don't realize is that Kepler 22b is an evolved Neptune. It's well on its way to becoming a water world. It's forming water oceans in its interior. So yes, this is going to be one of the ancient stars. It's going to begin the process of life formation. So they could study it and learn a lot from that object. But unless they adopt the understanding that planets are not mutually exclusive of stars and that they're not formed as byproducts of stellar formation, that a planet is the byproduct of stellar evolution itself, they're going to be forever lost in the sauce. Alright, I think that sums up the talk today. Hopefully people could hear that well. Later.